Hey everyone, we are starting chapter 5. This is our first lesson. I have it broken down. I'm calling this 5.1a. This is an introduction and we're going to build off of this. Chapter 5 is for us a very large chapter about quadratics. We're going to first talk about quadratics in the graphing form in two forms, vertex and standard form, which we're building into vertex form today. And then we're also going to get into solving quadratics by graphing. And we are going to spend time on factoring and solving by factoring, something called completing the square. We're also going to use the quadratic formula and solve using square root. So we are spending a lot of time in this chapter, and again it is all about quadratics. So we are moving on from linear equations and inequalities. So I already have this started for us. Using transformations to graph a quadratic function. A quadratic function, so we're going to be using this term a lot. A quadratic function is a function that can be written in the form ax squared plus bx plus c. This is one of those things you need to know. Ax squared plus bx plus c. And it creates a parabola. And you know what, I'm going to add in here the f of x equals. That makes me feel a little more comfortable since I'm calling it a function. Let's put it in function form, not an expression. Okay. In a quadratic function, the a, the b, and the c, a, b, and c, represent the location and shape of the parabola. And so a parabola is this U-shaped curve, not a V, okay? It's a U-shaped curve. And the a and b and c are coefficients. So a is the coefficient of x squared, b is a coefficient of x to the first, and c is a constant, but it truly is a coefficient of x to the 0 because anything to the power of 0 is 1. So if we're really looking at it, be ax squared plus bx to the power of 1 plus cx to the power of 0, because x to the 0 is the same as multiplying by 1. So I just want to throw that out there to remind you. So let's go ahead and start talking about this. We have something called the parent function. The parent function is the most base function that we start with, and everything builds off of that. So the parent function for linear is f of x equals x, or y equals x. Remember we talked about this, we put the 1 there and the 0 there. So when I go to talk about it, I'm going to use this as x, and this is going to be f of x. And I'm going to pick some numbers. I'm just picking -2, -1, 0, 1, and 2. You could pick whatever you want. I just randomly picked my x's, some positives and negatives. And I'm going to plug that in because this is my y value. So if I take -2, I would get out y is -2. And if I plug in y equals 1 times -1, I get -1. So y is equal to x, so I get these ordered pairs. All right, to show a quick sketch of the graph, here's my x and y axes. 1, 2, 3, 4. Get a quick sketch here. And I would plot my point at -2, -2, -1, 1, 0, 0, 1, 1, 2, 2. And we see that it would continue on. We can pick anything we want for x. So this is the line y equals x. It does have a y-intercept of 0, a rise and run of 1. All right, now let's talk about this one. This is where it's different. Instead of having x to the first, I have x to the second, which makes it a quadratic, where x to the first makes it linear, or a line. So again, same as y equals x squared. So here's x, here's f of x. Let's go ahead and use those same x values. There we go. And when I go to plug this in, it's really important to start this today because this is the biggest mistake. When I go to say x squared, you need to use parentheses. This is going to be a problem that's going to get you. Everything I square should be positive. That's a positive 4. All right, when I say -2 squared in parentheses, that means -2 times -2. I can't stress that enough. So everyone relies on these calculators. We put in -2 squared, not even looking, part of a big problem, and our calculator tells us it's -4. And the reason our calculator tells us it's -4 is it took -2 times just 2. That power is only on the 2, not on the negative sign. So you're going to get the wrong answer. It's not going to look like a U-shaped curve. Now, if I put it in properly, parentheses -2, and notice the power is on the outside of that. That's really important. The power is on the outside. So now it knows take -2 times -2, and there is my 4. So please start using parentheses everywhere you replace an x. The parentheses go right around there. So -1 times -1 we know is going to be positive. 0 squared, 1 squared is 1, and 2 squared is 4. So please start now. Note the parentheses, and that is crucial there, or you'll get the wrong answer. All right, here is my quick sketch of my graph. And I'm going to start at -2, +4, and that's up here. And then I'm going to go to -1, 1, 0, 0, 1, 1, 2, 4. That's what gives me that U-shaped curve, is the fact that whether I square the -2 or the +2, both outcomes are a +4. That's where that becomes that U, and you can see that it reflects itself over the center, which is called your vertex. Okay, so this is your parent function for linear, and when we take a quadratic, notice it's not linear, it's also jumping. If I would have made this 3 squared, I would get 9. So I would go 3 and it would jump up here. So we can see that it's growing quickly also, where linear is a constant change. If I would have done -3, I would have gotten a +9. And so we can see that this pattern extends. Okay, so notice the parent function of f of x equals x squared is a U-shaped curve called a parabola. So it's important that you know that term. As with other functions, you can graph a quadratic function by graphing points with coordinates that make the equation true. So we're going to do some point plotting. It's always a good thing to come back to if you're not sure of something. All right, so we have this quadratic, and it's x squared minus 6x plus 7. I'm going to make sure that looks like a plus sign there. Okay, so when I go to do this, this is basically telling me make x 1. They set up the table 1 through 5, okay? Make x 1. They plugged it in. I wish that they would use parentheses here too. And we're going to go ahead and evaluate that. So it'd be 1 minus 6 plus 7. And at this point, guys, you know, we can throw it in the calculator. We can do it by hand. If you're going to throw it in the calculator, again, be careful with your signs. Be careful with your parentheses. And we should get out a 2. Now, this basically wants you to rewrite it. So the x value is 1, and f of x, which is y, f of x, which is y, is 2. That's all it's doing. Please don't get confused by that. That's x, f of x is the outcome. So we put 1 in for x, and we got out the 2 for the y value, or f of x is 2. So same idea here. F of 2 would be 2 squared minus 6 times 2 plus 7. So here's what I would do. If you want to just throw it in your calculator, I would put in the parentheses 2, close them, and then square, minus 6 times 2. So I'm going to keep with the parentheses plus 7. And I get out -1. So when I put in a positive 2, I got out a -1. And now, if you want to save yourself a little time, I already have the problem in, so I'm just going to go in and edit over everywhere x was a 2, I'm putting in a 3, and I got out a -2. So 3, -2 is my next ordered pair. So let's go ahead and write that down. F of 3 equals 3 squared minus 6 times 3 plus 7, and that gave me -2. If I was putting in a negative sign, I would hit my second and my insert key, and that allows me to add an extra number without writing over everything. Oh, I just cleared everything. Let's try that again. Okay, so put in my 4, put in my 4, and I've got out -1. So f of 4 equals 4 squared minus 6 times 4 plus 7, and that gives me -1. So 4 gave me an output of -1. All right, last one, let's do f of 5, and that would be 5 squared minus 6 times 5 plus 7, and this time I went back up just to reread it in case I had made a mistake. Always double check what you're putting in, and I got out a +2. So put in 5, got out 2, input and output. Now, in the other problems we did, I picked some negatives and positives, and this problem, it was all positives, and that's because of the way this graph is going to be shifted. So this is something that we're going to learn as we move on. How did I pick these numbers? to get the full shape of the U, and we're going to talk about that at a later time. Right now it's given to you. So let's go ahead and plot and see what happens. So put your point here at 1, 2, put another point here at 2, -1, and then 3, -2, and notice it's wrapping back up at 4, -1, and then 5, 2. And there's your U-shaped curve. Now the reason I can connect this is X could be anything. So it wasn't just these points, these are the points I'm trying. Okay, so let's go ahead and let's start exploring what happens with our quadratics. So here we go. We have a check it out. So this would be a good place to pause and try this yourself. I want you to watch that negative sign. I'm going to go ahead and use the same number, so let me help you out there. We're going to put in 1, 2, 3, 4, and 5. And you could try any numbers you want and then make adjustments. So go ahead and pause this and give this a try and see if we get the same ordered pairs. Okay, so here's where my concern is. See how that's a 1 there? That negative sign is on the opposite. So the 1 goes in here, we square it, plus 6 times 1 minus 8. So when I go to put this in, I have negative and then my 1 in parentheses squared. So this negative is going to stay. It's the opposite of x squared. So everything we square is positive and we take the opposite of it. So plus 6, I'm going to go ahead and put the times 1 to use that later, and then minus 8. I get out -3. Now again, I can do this in my head, guys. It's -1 plus 6 minus 8. Double check yourself. The x value was 1 and the output, or g of x, was -3. All right, go ahead and do this again. I'm just going to fill these in. -2 squared plus 6 times 2, and then minus 8. The opposite of 3 squared plus 6 times 3 minus 8. The opposite of 4 squared plus 6 times 3 minus 8. And again with the 5. Okay, so I'm going to go ahead and plop these in. I'm just using my original, and I'm going in and filling in the 2's. Make sure you replace each x. And I got out 0. So that gives me an input of 2 and an output of 0. All right, next one, 3. Going in for x, I put in a 3, I got out a 1. So 3 went in, 1 went out. Remember, the negative sign was already there. All right, put in your 4. I get out 0. So 4, 0. Put in your 5. And I get out -3. So 5, -3. Now, I should get a U-shaped curve if I did this correctly. So there would be 2 things if I don't get a U-shaped curve. 1, I messed something up in my math, or 2, I graphed it wrong. So let's go ahead and see what happens here. 1, -3, 2, 0, 3, 1, 4, 0, 5, -3. Notice that my U-shaped curve is going downward, and that's because the x squared is negative. It creates a downward parabola, or a downward U. Okay, so that's something to remember. Whenever you square something, it makes everything positive. So whenever we squared these numbers, they all became positive, so our graph grew upward. But on the back, everything we squared became a negative. So whatever I squared became a negative. And so I had these outputs that pushed my graph to make it grow in a downward direction. All right, so let's go ahead and talk about some rules now that we've seen that. We have a horizontal shift of the absolute value of h. Remember, absolute value is the distance away from 0. So if I have f of x, the parent function, equals x squared, and I adjust that to be f of x minus h, that is going to equal x minus h quantity squared. And so the idea here is that the x value has been changed by moving it h units left or right. So my horizontal shift is left or right. So left or right movement. Now, when I go to do this, if h is if h is less than 0, it is going to move left. We'll say moves left. If h is greater than 0, it moves right. Okay, now that seems like the opposite. If h is less than 0, that's a negative number, and it is going to move it, and I think I have that backwards. Hold on. Just kidding. I want to talk about this here. So I have that h is less than 0, it moves left, and that makes sense because a negative number would move it to the left. If h is greater than 0, that's a positive number, it moves it to the right. But the problem is it doesn't look that way. See how this has h or x minus h? And the idea is if I have a negative h, what happens to that? So I have this x minus in here. See how I have x minus a negative h. That's going to end up looking like x plus h. And so when I look at that, a lot of people see, oh, it's a positive h, so that positive h is going to move it to the right. And that's not true. If I have x plus h, that came from x minus a negative h, so this is going to move it to the left. Be very careful. Notice it's x minus h. So if you see this plus sign, that meant it was a negative h, and a negative h moves it to the left. Now, if we have it the other way, where we have x minus h squared, well, that was really x minus a positive h. And so this is the one that would move it to the right. And a lot of people would see that and say, but it says minus, it's a negative h. The h stands alone. So the original is x minus. So the h stands alone. So we're going to talk about this. I'll make it a little more clear. Okay. Don't feel good about that description, so we're going to keep talking about it. Let's talk about a vertical shift going up or down. So parent function f of x equals x squared. And this time I'm taking f of x, I'm leaving the x alone, and I'm adding k on to the end. When we do that outside of the x value, that adjusts the y value, and the y value in your graph is your up and down. So if k is less than 0, it is going to move it down. Moves down. So if you have f of x equals x squared minus k, that's going to be moving it down. If you have that k is greater than 0, that moves up. And so that'd be f of x equals x squared plus k. So this minus and plus k, they sort of do what they say, okay? This is based on the opposite of h. So let's talk about these and make a little more sense of it. So using the parent function, x squared, as a guide, describe the transformations and then graph each function. Okay, so the parent function for x squared, if we did the parent function, f of x equals x squared, and we just made a quick t-chart here, and we do -2, we'd get 4, and -1 is 1, and 0, 0, and 1, 1, and 2, 4. So I'm going to go ahead and just plot that. So I go to -2, 4. This is the parent function. -1, 1, 0, 0, 1, 1, and 2, 4. So here's my parent function, just to sketch in, just to see. When you go to do your textbook homework, you will see that on all of the problems, I've already pre-graphed the parent function. So the parent function is here, and then you can see how it moves around. Okay, so that's why it's pre-graphed on there. Let me go ahead and just graph it here. -2, 4, -1, 1, 0, there, and there. Okay, so there's my parent function. Now, if we look at this, I want you to take a minute and rewrite it. G of x equals x minus a -3. Remember, that's where I get that plus from. Oops, I need an extra parenthesis there. Because the function is x minus h quantity squared, and so if I have a plus sign, that came from a minus a -3. So the h value is actually -3. Not 3, it's the opposite of that, minus a negative. So that means it's translated to the left 3 units. Okay, so if h is negative, it's going to move it left that many units. the k is added on outside of that quadratic, and so we are having k as positive 1, and since it's a positive, it's going to move up 1 unit. Translated up 1 unit. So we are just going to do a sketch of this. We're not going to make a table. We could make a table, but we're just going to sketch it. I'm going to take my original vertex of 0, 0. I'll move it left 3, 1, 2, 3. I'll move it up 1. And then I'm just going to do just a rough sketch of my quadratic. Should look about the same width. Again, you could get some extra points, especially since we know this vertex has shifted. We know the vertex is -3, +1, just by this information. So if you wanted a more accurate graph, what I would do is I'd put the vertex in the middle, okay? I put the vertex in the middle, and then I would build around it. Okay, here's -3 for x, so maybe I put in -4 and -5, and I want the other side, so maybe I put in -2 and -1. So that is how I get those numbers. I always put the vertex in the middle so I can build to the left and to the right of it. But right now, we're just looking at the translation and making a rough sketch. So this is extra for later. All right, let's talk about this one. This is already -2, so the h is actually a +2, and that can get confusing because we want to build that negative sign. The rule is x minus h. So that's why the h is +2. That means it's going to move right. Move right 2 units. I guess I don't need the word move there. It's translated. If you remember from geometry, translation is a shift change. All right, so right 2 units. And then we have a -1. So guys, it's really x minus h squared plus k. So the minus stays, h is 2, and k is actually a -1, because we can make this plus a -1. Okay, so that means it's going to move down 1 unit. So it says therefore g is the function translated. Okay, so we took the original function f and we translated it right 2 units and down 1. And I just realized that I didn't fill that in over here. So we took the individual shift change. So the new function g is the original function f, and it's translated left 3 units and up 1 unit. Okay, so let's go ahead and graph this. We start at 0, 0, that's our parent function, and we're going to shift right 2 and down 1. And again, we're just going to go ahead and put a sketch in. It should look about the same width, so I'm pretty close. Again, the vertex is exactly where we pushed it. The original vertex is 0, 0, where I can cut through this and make a line of symmetry. This is my original vertex at 2, -1. So the vertex is 2, -1. If I wanted a more accurate graph, I would plop that in the middle, and then I'd pick points to the left of 2, like 1 and 0, and I'd pick points to the right, like 3 and 4. And that is how I build my table. Okay, so let's keep going here. Spent a good amount of time talking about this, but again, this is an intro, so we're really building our concept. So we have a couple more here, and we're going to talk about how these change. So take a minute, pause your video, use your rules that we just talked about, and see if you can determine how these change. All right. So now that you've paused, I'm going to go ahead and graph that parent function. Remember, the parent function we have already mapped out from before. -2 squared is 4, -1 squared is 1, 0, 0, 1, 1, and +2 gives me 4. So go ahead and graph that. Whoops, maybe do a better job than me. 2, 4. And we want to graph that so we have this to base our new graph off of. And I'll go ahead and just plop that in here. And that is why I pre-did this on your homework. That way you don't have to keep doing it. So there is my parent function. Okay. Now, notice this one has no change with x. It'd be the same as writing x minus 0 squared minus 5. So if you think about that, and we go back to the parent function and those changes, this is what it looks like. So h is 0, so that means we don't shift it left or right, and k is -5. So we are just going to move our graph down 5 units. So I'm going to take this, I'm going to adjust it down 5 units to 0, 0, and again, I'm just going to do a quick sketch of what it looks like. The vertex, again, I'm adding this on because we're going to use this later. The vertex is at 0, -5. So you can find the vertex by using the h and the k values. Okay, the next one has a little more going on, so let's rewrite it. G of x equals x minus a -3. You don't need the extra parentheses, it's just proper. So when you think about this, it's x minus h squared plus k. And the more I rewrite this, wow, does that help my brain. So the h is not 3, the h is -3, and the k is a -2. That means we are going to move left 3 and down 2 units. So here's my vertex 0, 0. I'll move it left 1, 2, 3 and down 1, 2, and there is my new graph. And I'm just going to give a quick sketch in. So again, my vertex is the HK, which was -3, -2, and there's my new vertex. Okay, let's talk about a couple other rules. We're really going to focus more on these, and some of these we use more than others. So the reflection across the y-axis. I'll be honest, when you look at the reflection across the y-axis, I'm just going to make a note, it doesn't always look like it changed the graph. Does not change look of graph. So I just want to let you know, it really doesn't seem like it changes the look. So when I have this, you know how we have f of x equals x squared? The reflection of the x-axis is if you have, and you make it negative x quantities squared. That negative sign is what reflects it, but no matter what you do, it doesn't matter because you're going to square it. So if you have x squared, whether it's a positive or negative number, you're going to get a positive outcome. So if I have 2 and I say take the opposite and square it, I'll still have it. So it's the negative sign, negative inside square. And that's why you can put the negative in there. It's going to reflect it across the y-axis, but if I reflect this, you can see it doesn't look like it always changes the graph. Okay, now if my graph's over here, it will look like it does it. So it doesn't change the look of the graph, it just reflects it. Okay, now this we already saw, and we're going to see this one a lot. This is where it flips it over the x-axis. So flips over x-axis, and now we can still be shifting it. So when the a value is less than 0, now remember, the standard form of a quadratic is ax squared plus bx plus c, or it could be a times x minus h squared plus k. So this is your standard form, this is your vertex form. Either way, if that front number outside of the x squared is negative, it is going to flip it over the x-axis and give you that upside down. So when it's a negative and then x squared, so when the negative is outside, everything that was supposed to be squared and positive is going to be the opposite. So you're going to have this sort of upside down looking parabola. Okay, now this one's a little bit different, okay? And we're going to talk about this, and we're going to do some exploration eventually in an online program. So the horizontal stretch and compression by a factor of the absolute value of b. Okay, so if I have b times x squared, and it's inside here, okay, the absolute value of b is greater than 1, it's going to be, that's a 1 there, it's going to be more narrow. All right, it's a compression, meaning making it smaller, compression toward y-axis. That's what that one is. Now, if you have b times x squared, and it is between 0 and 1. So I'm talking about the absolute value. The positive or negative, that goes back up here, okay? It's just the number value, the absolute value of it. If it's between 0 and 1, it's going to make it wider, all right? And that's also the idea that it's inside the parentheses. So we're going to say that it stretches away from, whoops, y-axis. It makes it wider. Okay, so this is a compression or a horizontal stretch would be another way you would say it. So when you have a factor of b, this is inside the parentheses. Oops. Okay. A vertical stretch, when the a value is greater than 1. The a value is what's outside here. Okay, when I'm talking about b, that's a different b than this. When this is inside, it makes it a horizontal. When it's on the outside and the absolute value of a is greater than 1, it is going to stretch it away from the x-axis. So it is going to be a vertical stretch. It's going to look more narrow or skinnier. Okay, when 0 is less than the absolute value of a, which is less than 1, this is going to be a vertical compression. We're just going to make the graph wider. Vertical compression, or a wider graph. So we're talking ax squared, and the a is outside the square. All right, so let's take a minute and look at these. And again, we're just introducing, so we're going to do more work with these. All right, so last couple problems to look at here. And we are talking about reflecting, stretching, compressing the quadratic function. So if you look here, the parent function is that x squared. So I'm just going to graph that in again. So this is the same thing I've been graphing and reflecting. Graph that in. And then 0, 0, 1, 1. And graph that in. Okay, so a, the number in front of the x squared, is -4. So that means my, a is -4 or negative. So that's going to reflect, g is a reflection of the function f across the x-axis. Now, the absolute value of a is 4. So that means the function is going to be stretched. Oh, I should say, sorry, it says stretch. I should say it should be a vertical stretch. It's going to be a vertical stretch, or it's going to be more narrow. Okay? And that stretch factor is 4. So what happens when I go to do this? Well, this is a hard one to sort of just guess what the graph looks like. But we would not be moving anything. There's no addition or subtraction to x or the outside. So my parabola stays with the same vertex, but it's flipping. So it's going to look like this. And notice I made it skinnier or more narrow. So how would I do this if I really wanted a better idea? Well, I'd put 0, 0 in as my vertex. Okay. And then I'd pick something like -1, and I'd pick something like +1. And at this point, I'm off the graph, so that's why I picked 2 points. And if I go to put this in, it'd be a -4 times -1 squared, which is -4 times 1. And so -1 gives me out a -4. So I'd go here to 1, and I'd be right about there, and that would be where my graph goes. So let me just go ahead and fix this here. All right, so there's where my graph goes. And then if I put +1 in, that's -4 times 1 squared. So that's negative 4 times 1, and I get out negative 4. So 1, negative 4, and there we go. So I can see that I have a much skinnier graph, where when I put in positive 1 here, it gave me out only 1. Okay, now, why does that happen? Ignore the negative sign. The negative makes it grow in a more negative direction, but that 4 is making the y value grow 4 times as fast. It was 4 times 1, which made it 4 times as fast, so my y value is jumping 4 times as fast. All right, now let's look at this one. B, the value inside is 1/2, and that means that G is going to be a horizontal stretch. That means my graph is going to get wider, okay? Because it's between 0 and 1, it's taking half of its height. And it's going to be by a factor of 2, because it's 1 over that value. That's what tells me what's doing it. Okay, so how would I graph this if I was unsure of that? Again, this is going to start at 0, 0, and it's going to be a wider graph. Notice that the vertex again is 0, 0, because there's no vertical or horizontal changes. And so I'm going to put numbers in like negative 1 and maybe negative 2 and 1 and positive 2. And when I do that, I get 1/2 times negative 2 and I square it. Well, that's negative 1 squared, which I get out 1. And when I take half of negative 1, I end up with 1/2 squared, negative 1/2 squared, which is 1/4. Okay, so if I graph that, I would go to negative 2, positive 1, and I would go to negative 1 and 1/4. And so you can see that I've got this wide graph. If I put positive 1 in, I also get 1/4, and I put 2 in, I would get the same outcome of 1. Because half of 2 is also 1 squared, and that's where I get 1. So 2, 1, and 1 and 1/4. So you can see that I do get a wider graph there. Okay, last idea on the check it out. I don't have graphs built for this, but when I go to do this, this really simplifies to be g of x equals 4x squared, right? 2x times 2x, which is 4x squared. So the a value is 4, and it's positive. So it's going to be an upward u, all right? The graph is going to be 4 times as much. So it is going to have, it is going to be, let me see, growth is 4 times that, 4 times, oops, I can't write, 4 times the x squared value. So this graph is going to be upward u, and it's going to be more narrow. It's going to have a vertical stretch. Okay, now I have this negative 1/2 x squared, and so here the a value is negative 1/2. Okay, so that means it's going to be a downward u. It's going to reflect over the x-axis, so it's going to be a downward u, and because I'm taking half of it, it's going to be wider. Okay, so it is going to be a wider graph. And so I'm really looking for some generalizations on here. Okay, so give this a try. We're going to spend some time exploring some graphs in something called Desmos, which is a great online program. So you could also help yourself. If you don't have a graphing calculator, you can go into desmos.com and put in these graphs. You still have to understand the rules, but you can always see if you're getting them right by putting that in. Please make sure you work on your textbook homework, which are the next 2 pages in your packet, 5 through 13, 21 through 25. Give a quick description of what's going on. You can always make yourself a chart using your vertex to build around it.